Welcome everyone to another exciting episode of Dave Does Math from Home. Today's episode of Dave Does Math from Home is about section 1.3. We are doing applications, which is a really fancy way of saying we're doing word problems. Word problems are always an interesting topic of the class because I think that widely they're kind of everyone's least favorite problems. But also, this is definitely the most important section in the entire course. So, do your best. I hope you enjoy them. I think that for most people, the big challenge of the word problems is translating the words of the problem into the math of the problem. So there's sort of this translational issue where you're given a problem using a bunch of English words, and you need to transform that into a problem using a bunch of math symbols, and that's where the most of the difficulties lie. Once you get your math problem extracted out of whatever words are given, the math itself is usually pretty easy. It's basically just a matter of going from the words to the math. So that's mostly what we're going to talk about. There's no real hard and fast rules to this, so I'm just kind of going to go through a few examples and talk about general heuristic strategies for doing these problem solving. The first example I have is College A has 13,800 students in 2012. With expected enrollment increase of 1,100 students per year. In college B has 41,000 students with decrease of 600 per year. So the question is, in what year will the colleges have the same number of students? My personal least favorite thing about story problems is that writing them out takes a while and it takes up a lot of space, and now I kind of just have to erase most of this so that I actually have room on the board to do the problem. So I hope take a screenshot of this, or just go back to it on the YouTube video if you need this information again. I've got it written down on this piece of paper. So this is the question. It's about to be erased so that I have enough room to work on it. So the number one piece of advice I have for you when you're doing these story problems is label your variables. In this college enrollment story problem that we're working on right now, there's a lot of things that are changing. The enrollment numbers for College A are changing over time. They're increasing over time. The enrollment numbers for College B are decreasing over time. That's a change. The common factor here, and I think the crucial thing here that is varying, is time. So that's the variable that I want to really focus on. And we need a name for it. I'm just going to call it x. So for our problem, we're going to let x equal the number of years since 2012. So when x equals 0, that means we're in 2012. If x equals 4, that means we're in 2016. Now that we have this thing established for x, now we can start talking about the relationship between x and the other variables that we have going on here. Determine relationships. So let me name a couple more variables before I start determining these relationships. Let's say that A is enrollment at college A, and B is enrollment at college B. So these are the three changing quantities I'm going to be working with. We have enrollments at A, we have enrollments at B. Both of those things depend on X, the number of years since 2012. So now that we have our three different variables, we can determine all the relationships that we have between these variables. I think we know that college A starts with 13,800 students, and this increases by 1,100 per year. So when x is 0, this gives us the 13,800 number. If x is 2, that means that it has increased by this much twice, and so we add 2 of these to that number. B is 41,000 minus 600x. This is decreasing at 600 per year. So these are the relationships that we have going on in the story problem. Once we have these guys established, all we have to do is figure out what the question is asking us. The question is asking us, in what year are the enrollments equal? So real quick backing up thing. Usually the quantity that you want to make as like your main changing quantity variable thing is the quantity that the question is asking about. So somewhere in the story problem is going to be a question sentence. How many, or in what year, or wherever the question mark gets attached in the story problem, that's the quantity they're asking about, and that's the quantity that you should make be like your main variable. So we're asking when these things will be the same. So all we have to do is set A equal to B. If you set A equals to B, then you get 13,800 plus 1,100x equals 41,000 minus 600x. Once you have set them equal, this is the point at which we can sort of depart from the story problem bit. Because now what we have is a linear equation, and we know how to solve linear equations. We're really good at that. So from here, it's just math. We've successfully done our translation. Just math. We can finish this. The first thing I'm going to do to solve this particular story problem is I'm going to divide everything by 100, because these numbers just have too many digits. So that'll give me 138 plus 11x equals 410 minus 6x. So I will add 6x to both sides, and I will subtract 138 from both sides, And I will get 17x equals, what is that, 272? Probably, something like that. Yeah, that looks right. So we just need to divide everything by 17. And we should get that x equals, let's see, 10 of these would get us 170. So we need 102 more. So is that I don't think that comes out even. I must have copied down one of the numbers wrong. I think it was supposed to come out kind of even. That's all right. Will give us 10 plus 5 and change. This is about 16, 15 point something. It's 272 over 17. Not super concerned with the exact number. Because again, I feel like I copied one of these numbers down wrong. The last time I did this problem, it came out even. Anyway, that's not super important. What's important is once you've solved your linear equation and you get your answer for x, there's always a very important step where you reinterpret your answer with respect to x based on what the original question was asking for. The original question, as originally asked, is in what year will their enrollments be the same? The answer to that question is not 15. I'm pretty sure neither college A nor college B existed in the year 15. The year in which their enrollments will be the same depends on what X means, which is why this is still the first and most important instruction I can give you for doing these things. Determine and label your variables. If your variables are well defined and you have that written down, then once you know that X equals 15, you can just go right back to this and say, okay, what does X mean? X is the number of years since 2012. So 15 years since 2012. That means we're in 2027. And that's it. That's all you have to do. So you get your variables, you determine your relationships, you do math on your relationships until you have a result, and then you go back to step 1 with your result and you reinterpret that. That's the important thing here. So I think if I start another, I don't know, we can do one more on this video. So there will probably be a part 2 of this. But we do not have to start the part 2 right now. The second question I want to do is the length of a new field is 3 yards longer than quadruple the width. This must be a very long, very narrow field. Maybe this is like maybe this is some kind of like javelin field or like shot put or something. Some kind of track and field thing. Doesn't seem like a soccer field or a football field. Those are usually a lot wider than this. The perimeter is 446 yards. Find the dimensions. Okay. So again, step one is determine and label your variables. I think we should make L equal the length, and we should make W equal the width, and we should make, I guess we have the perimeter there, that's fine. So now we need to talk about our relationships, the relationships we have here. I know that the length of a new field means equals, 3 yards longer than means 3 plus, quadruple the width is 4W. L equals 3 plus 4W. This is one of the relationships that we have. The other relationship we have is that the perimeter is 446. Perimeter means 2L plus 2W. These are the two separate relationship things that we have. And in the last problem, once we established our relationships, we just sort of smashed them equal to each other because we were looking for when those two quantities were the same. Here, the way we're going to solve this, given these two relationships, is a little bit more complex. I'm going to substitute this whole business into this equation for L. So I'm going to take this and transform it into 2 times the quantity 3 plus 4W. That's this length. Plus 2W hasn't changed, equals 446. And now, after I have done that, now I once again have a linear equation. And we know what to do with linear equations. We can solve these guys. Let's see what that looks like. First thing I'm going to do is I'm not going to distribute here. I think this number is big, so I'm going to divide everything by 2. Probably should have done that here and just said L plus W is 223. So this is going to be, when the 2's are gone, this is 3 plus 4W plus W is 5W equals 223. So when you subtract 3 from both sides, you get 5W equals 220. And then you should get that the width is 1/5 of this. So 44. Once again, we're not quite finished. We need to go back to what the original question was asking to make sure that us solving this equation has adequately answered this question. Or maybe we need to do a little more if it hasn't. The question is, find the dimensions. So we have one of these. This is 44, and the only actual dimension that we're working with here is yards. It's 3 yards longer. The perimeter is 446 yards. So this is pretty clearly yards. I will expect you to label your units on your answers for all of these problems. So don't forget the yards. But also don't forget to find the length. The dimensions means both width and length. So right now we only have the width. We need to plug that number back into this thing so we can get the length. So we know that, I'm going to come over here for this, I guess, so I have room. We know that the length is 3 plus 4 times 44 yards. 4 times 44 is 176. Plus 3 is 179 yards. So there's your dimensions. The dimensions of this field are 179 yards by 44 yards. It's a very long, narrow field. I don't know what it's for. This is one of those problems that may not make sense in the real world. It's like those math problems about that guy who buys like 44 watermelons, and you're like, what are you going to do with 44 watermelons? I don't know what they're going to do with this field, but we have a long, narrow field, so I hope that's useful for them. We just hit the 20-minute mark, so I'm going to shut down this video. There is a part 2. Stay tuned.